We're going to move on to Chapter 4, Equations and Formulas. The contents include 4.1, Solving Equations, 4.2, Applications of Equations, 4.3, Business Formulas, and 4.4, Ratio and Proportions. Okay, a few definitions we need to review before we get too far into Chapter 4. When we use the word variable, a variable is a letter used to represent an unknown value. So, for example, we could use X, we could use T, S, Z, R, Y, or A. Any letter, it doesn't really matter as long as you know when you see the letter that's an unknown variable. I like to use the letter N to represent numbers. The word term. A term is a number, a variable, or the product or quotient of a number and a variable. So a term would be like 53, y, 6x, 9.5, 4 over 5y, s over 3. So we're really just talking about a number. A term is a number, but it could include a variable. So just y by itself is a term. But 6x is also a term. 9.5z, those are all terms. When we say an expression can be a single term, but it is often the sum or difference of two or more terms. So an expression, as an example here, it could be 7b, but more likely we're going to use the phrase expression when we're seeing something like 6x plus 9. That's an expression. Or z minus 1/2 y. Okay, doesn't quite, you don't have the equal sign in there, so when you throw the equal sign in, we'll see that that means something else. But right now, we're just the expression. An equation, oh my goodness, and the equation includes the equal sign. So x plus 5, that's an expression, but x plus 5 equals 9. Now we have an equation. And just remember that the equation has a left side and a right side, and based upon the equal sign, they must be equal. And then a solution to an equation is a number that can be substituted in place of the variable that makes the equation true. So as an example, x plus 5 equals 9. We don't know what x is, but you can see that x would be equal to 4 because 4 plus 5 equals 9. So x equals 4 is the solution to the equation x plus 5 equals 9. Okay, so the rules to solving basic or solving equations. Here you have two. The addition rule. The same number or term may be added or subtracted on both sides of the equation. So you have the equal sign. The left side is the left side and the right side is the right side. If you're gonna be adding or subtracting, then you must do it to both sides of the equation. The multiplication rule, both sides of an equation may be multiplied or divided by the same non-zero number or term. Actually, it is okay to multiply both sides of an equation by 0, but it's not okay to divide by 0, since division by 0 is not defined in mathematics. So here are some examples we can take a look at. The first example here, solve x minus y equals 15. So we have the equation x minus 9 equals 15. And we're trying to solve for the unknown variable. At this point in time, the unknown variable is x. In order for us to solve this equation, we must isolate the x. In other words, have it so that x equals something. So in other words, since it's already on the left side of the equation, let's see if we can make it so that it's all by itself. Well, let's take a look. We have minus 9. Well, the question is what do we do? What do we need to do in order to make 9 a 0? So it doesn't matter whether you're adding or subtracting. If it's 0, x plus or minus 0 is still x, all x by itself. Well, let's find a way to get it minus 9 to a 0. Well, in order to get that to a 0, we'll go ahead and add 9 to the left side of the equation. Well, minus 9, if you have a negative 9 and you add 9 to that, that's going to bring you to 0. So 9 minus 9 plus 9 is going to get you to 0. When you have that kind of a situation, if it's 0, x plus 0 is x, so you're left with x. And that was the objective, is to get to x being isolated on the left side. With the rule of addition, whatever we do to the left side of the equation, we have to do to the right side of the equation. Well, we added 9, so we must add 9 to, we're going to add 9 to the right side of the equation. 15 plus 9, you can use your calculators to make that work, but 15 plus 9 is going to be 24. So the answer is x equals 24. If we want to solve for that, we simply just replace the unknown variable with the results or the solution of 24, and we just look at it. 24 minus 9 equals 15. That is a correct statement, and that makes that x equals 24. The next one, solve k plus 7 equals 18. K plus 7, k is the unknown variable. The expression is k plus 7. The equation is k plus 7 equals 18. Now we have to try it again to isolate the k. In order to isolate the k, we need to figure out how do we take this 7 and get it to a 0. Well, we had a negative 9 and we added 9 to that, get that to 0. But in this case, if we have a positive 7, well, all we have to do is subtract 7. So looking from this perspective, plus 7 minus 7, that's going to give us 0. And that means k plus 0 equals k. So we are good. Whatever we do to the left side of the equation, we must do to the right side of the equation. 18 minus 7 equals 11. So what this suggests is that k equals 11. We can substitute the variable with the solution and see what the result would be. 11 plus 7 equals 18. Moving on to the next problem, solve 5p equals 60. 5p equals 60. Well, what are we going to do? Again, we want to isolate the unknown variable. In this case, the unknown variable is a p. So to isolate the p, we simply have to divide it by 5. So I don't know if you can see the division sign very clearly, but there's a line that I drew. So 5p divided by 5. 5p divided by 5. Well, through cancellation, we're going to cancel the 5s. The 5s will cancel, so they essentially turn into 1s. 1p divided by 1, well, that's going to leave you with p. So we've done it. We've isolated the p by simply dividing it by 5 in this case. All right, well, we have to remember that whatever we do to one side of the equation, we have to do to the other side of the equation. So we have 60 on this case. We have 60 on the right side. And now we're going to take 60 and divide it by 5. Well, let's do that. Let's take 60 and let's divide it by 5. 60 divided by 5 is 12. You can get your calculator out. Well, actually, oh yeah, the first chapter. So you're right. So 60 divided by 5 equals 12. If you had your calculator out, you could do that. I think I told you just the first 3 chapters and we're on the 4th chapter, so that's good. P equals 12. So that is your solution. Now to check the solution to see if it's correct, we simply we'll take the unknown variable and replace it with the solution. So 5 times 12 equals 60. If that's a correct statement, then you have it down. Let's look at the next one. Y divided by 3 equals 9. So, okay, so we have y divided by 3 equals 9. And what we want to do is isolate the unknown variable. So we want to make it so that y sits on the left side of the equation all by itself. Well, how do we do that? Well, we've got to figure out a way to get rid of this 3. So how do we do that? Well, what we're going to do is we're going to multiply y over 3 by 3. You could think of it as 3 over 1, right? So we're going to go ahead and take the y over 3 and we're going to multiply it by 3 over 1. Now, in doing so, what's going to happen? These 3's cancels out. What do we have here? We have 1 and we have 1 here. So 1 times y is y. 1 times 1 is 1. So you end up with y over 1. Well, y over 1 is y. Whatever we do to the left side of the equation, we have to do to the right. So 9 will be multiplied by 3 over 1. Well, because there's a 1 over the bottom here, we don't really have to, we might as well just say 9 times 3. 9 times 3. 3 over 1 is 3. So 9 times 3 is 27. So according to my computations, y equals 27. Moving on to the next, solve 3/4 z equals 9. Okay, so here's the equation, 3/4 z equals 9. 3/4 z equals 9. That's like saying 3/4 or 3/4 times z equals 9. We want to isolate the z. How do we isolate the z? Well, we're going to isolate the z by multiplying this 3/4 z by the reciprocal of 3/4 or 3/4. So the reciprocal of 3/4 z, the reciprocal of 3/4 or 3/4 is 4 over 3. Well, if we multiply 3/4 z times 4/3 or 4 over 3, then what happens? Well, same thing we talked about. This and this will cancel, and this will cancel. And what do we end up with? We end up with a 1 here. We end up with the 1 here and a 1 here. So 1 times 1 is 1. 1 times 1 is 1. So we end up with 1z. Well, 1z is equal to, it's equal to z. So we found a way to remove 3/4 by multiplying it by its reciprocal, 4 over 3. Whatever we do to the left side of the equation, we have to do to the right side of the equation. So we multiply 3/4 z times 4 over 3. Well, times, we'll take the 9 and we'll multiply it by 4 over 3. Now we're going to convert the 9 so that it now is written as 9 over 1, which makes it easier for us to complete the multiplication problem here. But before, we learned in the previous chapter, before we do this multiplication, we need to simplify or cancel out the 3 and the 9. 3 goes into 3 one time, 3 goes into 9 3 times. So we've simplified this by saying 1 times 1, that's going to be the denominator. The numerator is going to be 3 times 4. So 3 times 4 is 12. 12 over 1. 12 over 1 is 12. Example number 6, 2m plus 5 equals 17. So 2m plus 5 equals 17. Now, we still have to isolate the m, the unknown variable, the m. We've got a couple of steps now that we have to do this in. The first thing we need to do is let's get rid of the term that doesn't contain the unknown variable. The term in this case that does not contain the unknown variable is the 5. So how do we do that? Well, we did this earlier. if we have a positive 5 and we want to convert that or make that a 0, we simply have to subtract 5 from it. So we do that. So 2m plus 5, well, if we subtract 5, we're going to end up, after doing that subtraction, that's going to leave us 0. We'll end up with simply just 2m. Now, whatever we do to the left side, we have to do to the right side. So 17 minus 5 will leave us 12. 2m equals 12. And now, to isolate the m, we divide both sides by the 2. So we'll put a division sign here, we'll put a 2 here. And when we take 2m and divide it by 2, well, those two 2's are going to cancel, so that we end up with just m. Those 2 divided by 2, 2 goes into 2 one time, and 2 goes, so we have 1 over 1, 1m, 1 over m, 1m is m over 1 is m, so we're good. We're going to have to do the same to this side of the equation. And so 12 divided by 2 gives us 6. So in this example here, in this equation, 2m plus 5 equals 17. The solution is m equals 6. You could substitute the m with the 6. 2 times 6 is 12, plus 5 equals 17. Moving on to example number 7, solving a linear equation using several steps. 3y minus 12 equals 52. Again, we want to isolate the y, and so to do that, we're going to look at unlike terms. We know that 3y and the 12 are unlike terms. There's no y in 12, so there's not much we can do between these two in terms of addition and subtraction. But what we can do, since we have a minus 12, we can add 12 to the left side of the equation. If we have a minus 12 and we add 12, that's going to give us 0. So then what we have is 3y minus 0, if we add 12 here, so then that's going to leave us with 3y. Now, whatever we do to the left side of the equation, we have to do to the right. So let's add, and we're going to add 12 to it. So 52 plus 12 is going to give us 64. Now we have 3y equals 64. So let's go ahead and divide both sides by 3. The objective is to isolate the y. The only way we can get rid of that 3 is divided by 3. And whatever we do to the left side, we do to the right as well. So 3 divided by 3, those 3's will cancel. Well, essentially, they will both be 1. 1 over 1, 1 over 1 is 1, 1y is y. So after that cancellation, we'll end up with, which is what we want, y. And then we'll finish this off, 64 divided by 3 is 21.3333, which is really 21 1/3. Okay, the problems should tell you what kind of format they want them. In this case, they wanted a fraction. And here I gave you a decimal. All right, now in the previous problem I mentioned unlike terms, but meaning like the 3y and the 12, those are unlike because they both don't have variables in them. But now let's take a look at this particular problem we have. So example number 8 shows 8y minus 6y plus 4y equals 24. So 8y minus 6y plus 4y equals 24. Now in this case, what we can do is combine like terms. And when we refer to like terms, any term that has a variable that's similar to another term would be considered a like term. So 8y and 6y, because they both have y's in them, are considered like terms. The same with 4y as well. When we're trying to solve an equation similar to this, the first thing we want to do is combine like terms. 8y, 6y, and 4y can all be combined. And we can just kind of ignore the y for now and just look at the whole numbers. 8 minus 6, which will give us 2, plus 4 is 6. So if we combine these terms, 8y minus 6y plus 4y, that will give us 6y. 8 minus 6 gives us 2, plus 4 is 6. So we end up with 6y equals 24. And then to solve this problem, we're going to divide both sides by 6. That allows us to isolate the y. So 6 divided by 6, like I showed you earlier, those two will cancel, and you'll end up with just y. Y equals what? 24 divided by 6 equals 4. So the solution to this equation, y equals 4. Example number 9 is very similar to example number 8. It does throw in a decimal point, but for the most part, it will be solved exactly like it was before. So you should be able to figure that one out. The next objective number 5, is to review distributive property. And what we're talking about with distributive property is there can be a situation where we have a formula similar to this, where there are terms on the outside of parentheses, and then there's a plus sign with two terms in the middle of the parentheses. And when we have that kind of a situation, the question would be, or will be, how can we convert this expression in a way that allows us to continue to solve the problem? So I have this expression a times, in parentheses, b plus c, which in some cases will make it difficult for us to continue to solve an equation, because the format of this expression will be a little difficult to work with. So we need to find a way to convert this in a way that may make it easier for us to solve an equation. So here's the way I'm going to look at this. If I have an expression with a number on the outside and parentheses and two numbers, I will know that I can convert this by simply taking the a and multiplying it by the two terms inside the parentheses. So in other words, I can take a times b. So I'll take a times b, which will give me ab, and then I'll take that plus or minus sign, because this can be a minus sign as well. I'll take that plus or minus sign, carry it down, and then I can add that to a times c. In that process, I'm going to simply take ab plus ac. Using distributive property, then I know that a multiplied by a parentheses of b plus c can be converted to ab plus ac. AB brought down here plus AC. So the AB is brought here, the plus carries down, and then the AC gets carried down here. So this formula, or this expression, becomes equal to this expression. So that's how it's listed here. A open parentheses B plus C equals AB plus AC. When we do this, we're referring to the use of the distributed property to simplify equations. So let's put it to the test. We need to solve an equation that says 8, open parentheses, t minus 5, close the parentheses, equals 16. So let's do that. Okay, so here we have 8, open parentheses, t minus 5 equals 16. Well, if I use the distributive property that we learned, we should be able to take 8 times t minus 8 times 5. So this expression using distributive property would then mean that we're going to have 8t minus 40. 8t, that drops down there, the minus sign carries down, and 8 times 5 is 40. And that's still going to be equal to 16. So you can see how this would be difficult to resolve or come up with a solution for the t, but this is doable now. Now we're going to be looking to isolate the t. The first thing we'll do is we'll add 40 to both sides of the equation. After we have 8t minus 40 equals 16, we can continue to move forward to isolate the t. We'll add 40 to both sides of the equation. That will eliminate the 40 on the left side, which means we'll be left with 8t. And on the right side of the equation, we're going to add 16 plus 40, and that'll give us 56. So 8t equals 56. At this point in time, we'll go ahead and divide both sides by 8. 8t divided by 8 is going to leave us with t. And 56 divided by 8 will leave us 7. So in this example, t equals 7. On page 127, you'll see the steps associated with solving an equation. In most cases, we were doing most of this already, but you can review those steps and make sure that you've got them down when you're trying to solve equations. So now we have a little bit more complex situation where we have expressions that have unknown variables on both sides. The good news is that the unknown variable is the same. So for example, the problem here is 5r minus 2 equals 2 times open parentheses r plus 5 close parentheses. So we're to solve for the unknown variable. In this case, it's r. So in this case, we're going to take one side at a time to try to isolate the r. On the left side of the equation, it'll be pretty simple. We'll just add 2 to this side of the equation, which will give us 0, and then we're left with 5r. And whatever we do to the left side of the equation, we have to do to the right side. But in this case, instead of ridding ourselves of a problem, we end up with 4. Okay, so to solve this problem, the first thing we want to do is simplify the equation. Right now, it contains a term here that is difficult to use in resolving or solving this equation. So the first thing we want to do is use distributive property to lower this. So what we're going to do is, let's just go ahead and copy this down. And then using distributive property, 5r minus 2 will equal 2r plus 10. Now remember, to get to 2r plus 10, we simply took the 2 multiplied by the r, which gave us 2r. We carried the plus sign down, and then 2 times 5 equals 10. Okay. At this point in time, we have 2 expressions now that we could get close to solving. So using the simpler expression, we'll go ahead and add 2 to both sides of the equation. And after doing that, we're going to end up with 5r equals 2r plus 12. Now we can't combine the number with an unknown variable and a term with no unknown variable. So let's see if we can isolate if we can combine like terms, we could subtract 2r. And whatever we do to the right side of the equation, we'll do to the left side of the equation. So after doing this, we're going to end up with 3r on the left side of the equation equals 12. So by subtracting 2r from both sides of the equation, we have 5r minus 2r gives us 3r on the left side. 2r minus 2r means we have 0, which means we're left with 12. So we're left with the equation 3r equals 12, and that should be pretty easy to solve. I'm going to divide both sides by 3, and that would then mean that 12, and that will mean that r equals 4. Yep, well, you got it. Next problem, again, is pretty similar. The only tricky thing is it adds decimals, but you could use distributive property to resolve it, and I think you'll be all right. That completes exercises 4.1.